Hello viewers, in this lesson we are going to learn several things, and that include bearing and distance, geometrical construction, upper and lower bound of a measurement, probability and percentages, using a past question from IGCSE October November 2019. We are looking at paper 3 in the core curriculum, question 8 to be precise. I think it's better I show you the question so that you know what I'm talking about. This is a paper, October, November 2019. I'm looking at paper 31. Paper 31 there. That is it there. You can download it and follow along. Paper 3, 2019, October, November. And the question says, the scale drawing shows the position of two buoys A and B in the sea. The scale is 1 centimeter represents 20 kilometers. So this is the drawing here. You can see the position of A here. This is buoy A and this is buoy B. And this curly line here is the sea. And the scale is 1 centimeter to 20 kilometers. Okay, so what do they want us to do? Go down, it says, work out the actual distance between buoy A and buoy B. How can we get that? Of course, we need to measure the distance between A and B using a ruler. Then I place my ruler in a way that the beginning, the zero mark is on A, and then measure to B. You shift it closer so you see it clearly. When measuring something like this, make sure that the zero is on the reference point or one of the reference points in this case. So I'm taking A as my reference point, then I measure down to point B. Based on what I have on my ruler, that is 11 centimeters. And the question says you should work out the actual distance. What does that mean? 11 centimeters on the map represent what distance on the land. To do that, we use our scale, which is 1 centimeter to 20 kilometers. So if 1 centimeter is 20 kilometers, what will be the 11 centimeters we just measured? 11 centimeters, let it be what? X. And by simple proportion, we can find the value of X. How do we do that? You cross multiply. This multiply this, that is 11 multiply 20, and 1 multiply X. 1 times X is of course X, so X is equal to 20 times 11. 20 times 11, that gives us 220. So 11 centimeters on the map is equivalent to 220 kilometers on the land or on the ground. That is the actual distance I want you to find. So you go here and put the answer, 220 kilometers is the actual distance between buoy A and buoy B. So that is 2 marks there. Then the second one says, measure the bearing of buoy B from buoy A. Bearing of B from A. B from A. B from A. Take note of that. So A is our reference point. We want to get the bearing of B from A. How can we do that? First, let's join A and B with a line, and then measure the angle that is between A and B. That will give you the bearing of B from A. So I'm joining point A and point B with a straight line. Okay, that is the line there drawn. Oh, okay, I joined the two with a straight line. And the bearing of B from A will be this angle here. This angle. Remember, bearing is measured from north in the clockwise direction. So measuring that angle will give us a bearing of B from A. And remember, to measure an angle, we need a protractor. Yes, my protractor. My reference point is A, so I make sure that my baseline is exactly on that line A there. That line that is showing up there, the baseline must be on it. And the point of intersection of the baseline and this angle 90 here must be on this reference point here, point A. This point here on the protractor, that is where the vertical and the horizontal line meets, must be on this very point here, so that you can measure the angle accurately. So place it like this. I think it's right there now. Let me adjust it a little again. Okay, I think that is good enough. So based on what I'm seeing here, the angle is 80 degree. The angle is 80. That is, I read all the way down here until I meet the line already drawn. So the bearing is 80 degree. 80 degree. And bearing, of course, you have to write it in 3 digits. So that is 080 degree. So the bearing, putting it in the answer here, have 080 degree. That is the bearing of B from A. Now the third question says, where is it? The third question says, boy C is 120 kilometers from boy B on a bearing of 300 degree. Boy C, that is another one entirely that is not yet on our diagram, but they give us the distance from B and the bearing also from B. So how can we get that? B is our reference point in this case, so we need to get the angle of 300 degree from B. So using B as reference point now, my approach here is to draw or extend this line, kind of making some cardinal point there so that we can get the angle accurately. So let me extend this line down. Extend. Also do another one here because I want to use it to explain something right there. Okay, now that is not perfect enough, but hope you have an idea of what I want to do. These 4 cardinal points here, which form a 4 quadrant, give us 90 degree each. This 90, 90, 90, 90. 90 plus 90 is 180, plus another 90, that is 270. So our 300 should be in this quadrant here. And recall that the whole of the quadrant, that is, if we add the 3 of them together, is 360 degree. There's no way you can use protractor to measure 300. So the logic is to subtract 360 from, or is to subtract 300 rather from 360. The remaining one will be the angle from this point. In this case, I'm going in anti-clockwise direction now. I'll measure 60 degree. That is 360 minus 300 give me 60 degree. So the angle from here to here is 60 degree. The remaining one from here down to this place will give me the 300. So if I measure 60 rather from that point, I'll place my protractor in a way that where the baseline and the 90 degree meet must be on my what? My reference point, which is point B here. So let me clean on this other line that I drew so that it will be clearer. I drew those lines just for explanation. So this line here, this point, this very point on the protractor must be on this point, and this baseline must also rest on this reference line here. So place it like this. Okay, that is it there. And measure 60 degree there. Here is my 60. Hope my hand is not blocking it. Here's my 60 degree right there. I'll put a mark there. The mark there. That is 60 degree. So, and then draw a line from that point to my reference point, which is B. I place my ruler and join this point B with that point there. Okay, so that means, remember that bearing is measured from north. This line, I clean part of it, so let me redraw it again. Okay, bearing is measured from north in clockwise direction. So they say the bearing of point or buoy C, where is it? Let me show you the question. Buoy C is 120 kilometers from buoy B on a bearing of 300 degrees. So what we have drawn here from this side all the way down to this place is the required 300 degree. Why the remaining one, which we measured so that we can get this line, is 360 degree. Remember, you cannot get 300 from your protractor. So when you have such a large angle, the best approach is to subtract the angle given to you, 300 in this case, from 360. Then measure the remaining one from north in anti-clockwise direction. That's exactly what I did here, measuring 60 degrees from north, going in the anti-clockwise direction. So this 60 degree here minus 360 give me my required 300 degree. So here is the bearing that we need. Okay, but they said that that very point C is 120 kilometers from point B. So we need to do that part of it. First of all, we need to convert that 120 kilometers to centimeters so we can know the equivalent line in centimeter. Recall that our scale is 1 centimeter to, let me do the conversion here. 1 centimeter is 20 kilometers. 20 kilometers. So what will be 120 kilometers? Let it be x. X centimeter will be 120 kilometers. To get the value of s, we do simple proportion, s times 20 and 1 times 120. So s times 20 is 20x equal to 1 times 120 is of course 120. S therefore is 120 divided by 20, which is 6 centimeters. So the centimeter is 6. 120 kilometers is equivalent to 6 centimeters using our scale. So this length of line here from B to this point should be 6 centimeters. So let me extend that to 6 centimeters. And place my ruler in a way that, oh, that is not showing. This is 6 centimeters right there on the reference point, point B. Adjusting it a little. Okay, I think it's right there now. And I draw it to 6 centimeters. Okay, so that is point C right there. Let me mark it. Point C. That's my point C here. Okay, so that is that for that. Then we go further. We have done where are we now? Okay, this is where we are now. So on the scale drawing, mark the position of buoy C, which we have just done. Then IV, that is the fourth question, is Marco sails his boat so that he is always equidistant from buoy A and buoy B. On the scale drawing, use a straight edge and compasses only to construct the path of the boat. Show all your construction acts. Okay, the keywords here is Marco says his boat so that he is always equidistant from A and B. Equidistance from A and B. Where is A and where is B? This is A and this is B. So this guy is sailing in a way that is always in equal distance from this point. That means we need to bisect this very line here. And to bisect a line means to divide the line into two equal halves. So the locus of point that bisect line AB will give us the position of Marco's boat. How can we do that? Take your pair of compasses, place the stick point on one reference point, open this pencil point to any considerable length, make an arc. Make sure that the pencil point is more than half the length of line that you want to bisect. So I'll open it to 3/4 of the line, then make an arc. Make an arc here. Oh, sorry about that. My table is slippery. Let me start all over again. Make an arc there. Then make another arc here, right here. Remember, I've made the first arc here with the same stick point or with the same dimension. Make the other arc there. Then take the stick point to the other side of the line, that is point B this time around. Make sure you don't close the compass. Cut the arc previously drawn. That is that there. Then come down and do the same thing here too. Cut it right there. Okay, so those are the arcs drawn. Let me show you very well. Those are the two arcs. Now, where the two arcs intersect, join them with a line. That will be a locus of point that is equidistant from A and B. And that is the path of Marco's boat. Let's join that. Let me use dotted line so that. Okay. That is it right there. That is the locus of point that is equidistant from point A or from boy A and boy B, according to the question. So what did he say? Say Marco says his boat so that he's always equidistant from boy A and boy B. On the scale drawing, use a straight edge and compasses only to construct the path of the boat. Show all your construction arcs. So that is what we have done here now. This is the path of the boat of Marcos. We did that by what? Bisecting line AB, because they say equidistance from point A and point B. To get a line that is equidistant from these 2 points, bisect this very line, which we have done. So that is that for question A or 8A. Now we'll go further. The B part says, it said the amount of fuel, T liters in the boat's fuel tank is 135 liters. Correct to the nearest liters. Complete the statement about the value of T. Dash 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 is less than or equal to T, and is less than or equal to dash dash dash. That is, we have to fill in this gap here. And this question is on what we call the upper and lower bound of a number. Now, to get the upper and lower bound of a number, my best approach is to represent the number on a number line. And what is the number here? The number is 135. So I want to get the upper and lower bound of this very number. So I will rule my number line. My number line is right here. Then place the reference number at the center of the line, 135. Now, if we are representing numbers on a number line, and here is 135, the next number to it should be 136, because the question says to correct the nearest letter, that is, they round off or round up a number to give this very number here. So to the nearest letter, that is whole number liters. So the next whole number to 135 should be 136. And the next, or the number that comes before 135, the whole number that comes before it rather, is 134. 134. So the number in between 134 and 135 should be the lower bound of this very number. Again, the number between 135 and 136 should be the upper bound of this number. What is that number? You can get that by adding 134 to what? To 135, then divide it by 2. That will give you 134.5. 134.5 will be the lower bound of that number. To get the upper bound, you add 135 to 136, then divide by 2, which will give you 135.5. So the lower bound of this number is 134.5. Fill it right here. 134.5 is less than or equal to t. Of course, you can round up 134.5 to 135. That is what that statement means. Then the upper bound is 135.5. You can see here the symbol is less than, because there's no way you can round up 135.5 to 135. If you round this up, it's going to give you 136, and that means this number is not in the range of t. That is why there's a less than here. But here is less than or equal to. This number is less than or equal to the value of t. The value of t in this question is 135. So the lower bound of this number is 134.5, while the upper bound is 135.5. That is the required numbers we have to use in filling this gap. That thing that is not showing very well, so let me write it again. 135.5 is the number there. Okay, so that is done. Then the C part of this question says Marco has ropes of 4 different colors. He takes a rope at random. The colors are brown, white, red, green. The probability 0.35, then this is blank, 0.04, and then 0.2. Complete the table. There is this missing number here, we have to fill it. Now, the probability of picking a rope of brown color is 0.35, that of red color is 0.04, that of green color is 0.2. Now, all the rope he has is brown, white, red, and green. If we add the probability of the 4 of them, it should be 1. That is, the sum of all the probabilities should be equal to 1. So, to get this missing probability, add this, and this, then subtract the result from 1. So, we have 1 minus, excuse me, 1 minus 0.35 plus 0.04 plus 0.2. That will give us 1 minus, let me use my calculator to add those decimals. Have a 0.35 rather plus 0.04 plus 0.2. That is 0.59. 1 minus 0.59 gives me 0.49. 0.41 rather. So the missing number here is 0.41. That is that. Then question D. It says, when Marco arrives at a port, the temperature is 5 degrees centigrade. At midnight, the temperature has fallen by 7 degrees centigrade. Find the temperature at midnight. Now, the initial temperature is what? 5 degrees. Then the temperature fall by 7 degrees. The difference will be 5 minus 7. 5 minus 7 is minus 2. So the temperature at midnight is minus 2 degrees centigrade. Then the question E then says, last year the cost to keep a boat at the port was $14 per night. This year the cost has increased by 12%. Calculate the cost this year. Last year the cost was 14%. That increment is 12%. 12 plus 100%, that is 112%. So the cost for this year is 112%. This year cost is 112% of this very amount there, which is 14. I have 112 divided by 100 times 14. That will give me, let me use my calculator. 112 divide 100 is 1.12 times 14. That is 15.68. So the cost this year is 15.68. 15.68 is the cost this year. And lastly, St. Marco watched 25 boats enter the port, of which 9 had a mast. There are a total of 200 boats in the port. Calculate an estimate of the number of boats in the port that have a mast. Now, to get the number of boats that had a mast, we need to get the probability of obtaining a boat or seeing a boat that had a mast. Now, they said there are a total of 25 boats that enter the port, and out of that, 9 had a mast. So probability that a boat had a mast is 9 over 25. The probability of boat with a mast is 9 over 25. So number of boats that will likely have a mast is 9 over 25. That is the probability multiplied by the total number of boats that enter the port. So number of boats that likely had a mast is equal to 9 over 25 times 200. And that will give us, let me use a calculator for that. 9 divided by, or 9 times 200 divided by 25. 72 boats is an estimate of number of boats with a mast. 72 is a required number there. And this brings us to the end of this question. I hope you enjoy it. If you do, don't forget to like the video and also share it with your friends. Also subscribe to the channel so that you can get more of this as I release more content. God bless you.